Hello, world. This is the Ranyo and DaRon podcast show. I am Ranyo.
I am DaRon. Welcome to episode 5. Today we're going to discuss deserialization and serialization issues and attacks that very few people talk about and largely go unnoticed within our industry. So just to start off with, I'm going to point out something really interesting. We've created a super vulnerable Java application, thus its name. And this particular application leverages a SQLite database backend and jOOQ. If you haven't ever worked with jOOQ, it is an absolutely positively phenomenal Java library that is dedicated to providing you a solid means of performing SQL queries without the fear of being tied down to any particular database or having issues due to things like SQL injection. So if you haven't ever looked it up, I strongly recommend it. It comes out of Switzerland, and the development team is absolutely rock solid. They're also very responsive, and Lucas, I'm sure I'm mispronouncing it because it's Swiss, is incredibly responsive if you have any questions, comments, or concerns. So real quickly, what I've done is, as part of our build, we've hooked it up so that it will actually automatically look at our SQLite database, and then it will generate a variety of DAO layer methods and things of that nature for us, and a series of records based on the structure of the database. And that's an important first step, and I'm going to go through now and just build the application. So importantly, remembering that this is in fact a Java application. The next thing I'm going to do, this is running Struts 2, actually the latest version, 2.5.26, I believe it was, something like that. And it's running in a Tomcat environment. So we have tied to this application just one action of use, and that's really this project's action. You'll notice we have our own JSON writer. The reason why we do that is because the default Struts 2 JSON writer, like much of Struts 2, is just horrible, is incredibly poorly written, very inefficient, and incredibly insecure. And I stand by that statement. And if you are a developer of it, you should be ashamed. But you can feel free to contact me. I'd love to point out how vulnerable you are. So looking at this, I'm going to point out a few quick things for those of you who aren't familiar with the way Struts works, or with the way Struts JSON plugin and things of that nature work. That may or may not be useful. So we have project's action. Now project's action extends REST action. So within this, we have a few different variables of use that we actually can go through and manipulate if we so choose. Here within the Struts action itself, we've got the variables project ID, project, and projects. You'll notice projects is a collection, and that's going to be important as we talk about this a little later on. So the way this operates, we currently don't have sessions and things of that nature or authentication on this particular product because it's not important to what we're demonstrating today. And we actually only recently started building this out. But we have this show method, and then we have another method called index. The way these wind up working, if you don't provide an ID, then being a RESTful application, you're going to get an index for that, which means it would show you all projects that are in the system. Whereas if you provide it a specific ID, it calls show, and you'll notice here, we will show you that one object and retrieve it from the database. So something very important to note though, tied to all of this, is the fact that we happen to have this project inside of here. Now, project is a VO of its own. project goes through and it points to something called item VO. And you'll notice we have this modified by user, modified date, and modified by, as well as an ID. ID is the ID of the item. So if you're talking about a project, it would be the ID of the project. Modified by whomsoever modified it last, so on and so forth. Now, this application is going to work a little differently than some applications, and then some VOs wind up working. So some VOs don't do this kind of thing. There's no logic. Every method, every getter is like this one here, where it just returns whatever happens to be set. That's not really pertinent to what we're doing today. Whether you bury it inside here or bury it inside of the BLO layer or the business logic layer, or you bury it inside the data access layer or anything like that, that's actually moot for what we're going to be doing today. But I've provided a mixture here just to give you a good quick idea. You'll notice again, this modified by is just your standard getter. I'm sorry, your modified date is a standard getter. Modified by does one simple thing. All it does is check to see if it's null, and if it's null, it checks to see if modified by user is null. If modified by user is not null, then it will go through and grab that user ID from it. So fairly straightforward. Now on the other side, our project VO is very straightforward. Get file returns the file, and that's it. Get title returns the title, and that's it. You'll see very straightforward VO. Nothing fancy, nothing extra tied to this. Now, importantly, we do have for project VO this concept of file. That's important because we're going to abuse that momentarily. So file, of course, points to this guy here, which has two variables in it. It has file and then it has contents. Now contents is a byte array. That's important. We'll get to why shortly. Whereas file is really just the file name. And you'll notice that file is a string. So we have get contents in here, and get contents works a little differently than a lot of what you would normally see. Usually we'd call to a BLO, but for the purposes of this, just to make more impactful what we're showing, I have inserted some rudimentary logic into this VO. Again, it's not actually necessary to this demonstration, and we'll go into why. You'll also notice that we grab the file size. This is actually more common and something you see considerably more frequently. All right, so let's start off by actually running this puppy. So you'll notice here we've got, of course, our super vulnerable Java application. When we run a basic get, we see this data come back. Now remember, since we didn't provide a project ID, what we wind up getting is this listing of all projects. At the moment, we only have one. Now you'll also notice some little oddities. It, by default, is actually recursively grabbing all of the other data. Now that's going to be important here. That recursive grabbing of all of the data by the JSON plugin, when it's serializing it, is something we're going to abuse. That means that it's running the getters for grabbing that username and things of that nature. Now that would be something that would be useful and something that you would normally have be exposed like this inside of an admin console, or maybe for the purposes of showing revisions to our project. But let's go through, let's check out how the system behaves when we give it a project ID. So you'll notice last time it said projects, now this time it says project. So remember, projects is a collection and project is a singular object. So we see our project ID has been set. We see our ID, we get that same data that we had before. So that's all well and good. But now if you remember, we had that REST action. REST action happened to have a couple of variables, one of them being nonce. You'll notice how our nonce is reflected back to us. And this is actually vital because it's actually not being reflected back to us. What's happening is we're actually utilizing Struts' deserialization, and we're setting our nonce, and here I just set my session ID. Now that doesn't mean anything because we don't happen to have sessions at the moment, but if we did have sessions, this would be a convenient way of going through and doing session hijacking or hopping, as the case may be. It would also be a great way to enumerate. But let's do something maybe a little more interesting. We did notice that this system is spitting out this data. Now, we could have gone through and made it so that by default, it actually sets that modified by user data to null, which means that it would have been returning null and it wouldn't be returning any of this data. But like I said, that's actually moot. That doesn't make a difference. Now, the reason why that doesn't make a difference is because I, as a malicious person, can actually set your modified by data. So now what we're going to do is let's go through and attack this by creating a fictitious project. So we're going to say project.id equals 2, because that project doesn't exist. And project.title equals like this. We'll have it return. So you notice it spat back out what we wanted. So let's do something else. Let's start enumerating users. So we see here project dot, let's say by equals 2. And you'll see here, we changed it, and we know we successfully changed this because it automatically gave us back that data, which is different than what we saw for ID of 1. Now, when we set it to 3, instead of Bill, we get Bob. You'll notice none of these guys have logged in. All right, now let's get a little more interesting. So we remember project had files, right? And file, of course, had the name file. So let's try this. All right, so what we got back was a file size of 0, and here's our path. That's great. So we're on a Linux system. Now it's spitting back that contents. Importantly, even if it didn't spit back the contents, let's say the contents didn't automatically grab, you did have to go to a BLO or something of that nature in order to get those contents. We're still able to tell that this file exists based on that file size no longer being 0. As demonstrated by the fact that this now returns a different file size. So that's one of the really important things to recognize, is that our serializers can be abused. In this particular case, we're using our serializers to actually create an entire object and then stuffing that object with whatever we want. And as we've noticed, we can sit there and stuff anything so long as it has a setter that we have access to. But importantly, it goes even beyond that. We can actually trick the system into creating processes and things of that nature. That's actually one of the major Struts vulnerabilities, Struts 2 vulnerabilities, that keeps coming out over and over and over again. They have been unable to successfully kill that for over 4 years now. They keep getting vulnerabilities tied to the same exact thing. And this is not something that is particular to Struts. Again, unfortunately, a lot of systems are built off of Struts, such as Spring, and they suffered the same exact serialization, deserialization, insecure serialization vulnerabilities, and insecure deserialization vulnerabilities. But they're not the only ones. ASP suffers similarly to this. Now, I'm just going to give you another example. In this particular case, we're going to actually attack it via JSON strings. You'll notice we're running a get. So this isn't, and last time we were running a get too. It's not like we're doing a post or a push or anything like that. So in this case, we're actually going to run a show. So we grab the project data. You'll notice this time our attack is actually geared toward projects itself right here. So projects goes through, and you see we created our own collection. Now, one of the beautiful things about the JSON Struts plugin is it allows us to serialize and deserialize anything that is a string, a number, so those are, things like, of course, integer, long, etc., big decimal, big integer, map, collection, or Boolean, as well as arrays. And what that means is we can go through and we can create these arbitrary deep objects, just like what we were doing here, but it's actually much easier in JSON than it is outside of JSON, because no longer do I have to sit there and keep track of all my periods and all that good stuff. I can go through and create well-formed JSON, run this through something, and I could literally take existing JSON and just modify it. Now, interestingly enough, you'll notice this description here, and this is actually really interesting. So right now what we're using is actually the OWASP current HTML sanitizer. This is the one that they advertise and they create and push and all that other stuff. Now, importantly, this thing by default encodes certain characters, specifically the @ symbol. Now, the reason why that becomes very, very important is that breaks a lot of React and AngularJS software. The reason why that breaks it is because if I am going through and sanitizing all input, which is what's going on here, so everything that gets input gets run through here, and it's throwing in this random @ symbol, and some of my input, for example, titles, cannot have HTML, while others can only have specific HTML, in this case, paragraphs, but not things like links, then it means that I have no real way to properly sanitize all my data. Because if I use this here, they will throw in that @ symbol. And the reason why that becomes a problem is inside of React or Struts or Angular or AngularJS, when it's going through and it is attempting to utilize what got pushed to it from the back end, what it winds up seeing is that @ symbol that has been encoded, and it will literally print a literal @ if you don't disable escaping. Now, I wouldn't disable escaping for the title. I would disable escaping because it's supposed to be trusted for the description, which is why we do it that way. But the problem is I have to sit here, because if someone had an @ symbol inside the title, I don't want it to print out ampersand #64 semicolon to the user. I want it to print out an @ symbol. What that means is we have to do this decoding HTML. But what that then does, and you have to decode the HTML after you've had the OWASP sanitizer go after it. Now, while this application will properly filter out my @ symbol, what it will not filter out, and we can see that @ symbol. So this, see how that link has been removed? This HTML encoded version of it, which is right here, in fact persists. And all we did was this. Now, this kind of encoding attack is unfortunately almost impossible to prevent if you're using the OWASP HTML sanitizer and you have what's called mixed content where you have to sit there and have rich text, and content where you don't. The only way around that is if you use the HTML sanitizer, then you have to disable all HTML escaping across the entire, be it React, Struts, JSP, Angular, AngularJS, or whatever front end. So that's one of the critical issues with something like this. Hopefully you can see the dangers of serializing and deserializing. Again, we wanted to show something different than what you see in some of these fancy presentations. This is considerably more common than, for example, being able to run arbitrary code because of a parser problem. This is not attacking your parser. What this is attacking is your actual structure using the parser, rather than doing a deserialization attack where I'm pushing bytecode or where I'm pushing just straight queries and things of that nature, processes, etc. This winds up producing similar effects, and it's oftentimes overlooked. Well, with that, we're going to leave off this episode, and I want to thank you all for watching.
Until the next time, don't forget to subscribe to the Ranyo and DaRon podcast show and catch you the next episode. Signing off, I'm Ranyo.
I'm DaRon.
Have a good one.
Have fun.